In this video, I'm going to show you how to differentiate using the first principle. If you have y is equals to x squared, using the general rule method, we should have derivative of y is equal to x squared is simply dy dx is equals to 2x, right? So using the first principle method, the rule says a little change in y also leads to a little change in x. So a little change in y plus change in y will lead to a little change in x, which is x plus change in x squared, right? So we have the left hand side is y plus change in y equals to, so I'm going to expand this whole of thing. So we have x squared plus 2x change in x plus change in x squared, and then I need to bring this y to the right hand side. So we have x squared plus 2x change in x plus change in x squared minus y, and then the y, change in y rather, is equals to x squared plus 2x change in x plus change in x all squared minus, but then we know y is equal to x squared from our original question, right? So y is equals to x squared from here. So I can just replace x squared for y. So we have x squared. So here x squared can cancel out x squared. So you are left with change in y is equals to 2x change in x plus change in x all squared. So the next thing I'm going to do is to divide all through by change in x. So if I divide all through by change in x, I have change in y over change in x, 2x over change in x, and the x squared over change in x. So change in x can cancel out change in x here. Change in x cancel one of the change in x, so we are left with change in x here. So this is the same thing as 2x plus change in x. So we have change in y over change in x is equals to 2x plus change in x. So the next thing to do is to limit change in x towards 0. So we have to take the limit of change in x towards 0 in the limit of change in x. So if I take the limit of change in x towards 0 here, so we have the y dx equals to 2x plus change in x here is towards 0, right? Here, so I need to set it to 0, so we have 2x plus 0, which is the same thing as the y dx is equals to 2x, and this is our final answer.